In 1931, American engineers faced a problem no one had ever solved before. The Colorado River, one of the most powerful, most unpredictable rivers on the entire planet, had to be completely stopped, not slowed, not redirected, stopped, brought to a standstill, the middle of a deep desert canyon, in temperatures that routinely exceeded 120 degrees Fahrenheit. And they had to do it without modern computers, without GPS, without the advanced machinery we take for granted today. They had nothing but hand tools, dynamite, raw steel, and thousands of desperate men who had traveled from across America just to find work during the worst economic collapse in the country's history. What they built didn't just hold back water, it rewrote what humanity believed was physically possible. Now the story of how they did it, the engineering decisions, the sacrifices, the near disasters, is something most people have never fully heard. A problem. To understand why the Hoover Dam had to be built, you first have to understand the Colorado River and why it terrified an entire region for generations. The Colorado River runs over 1,400 miles from the Rocky Mountains all the way to the Gulf of California. Every spring, when the winter snowpack began melting, billions of gallons of water surged down through the desert in a violent, uncontrolled flood. The river's color would change from blue to a deep reddish-brown, carrying so much sediment that it could destroy crops, collapse bridges, and bury entire farms in thick layers of mud within hours. Towns along the river had no defense. Farmers who had spent years building irrigation systems would watch them wash away in a single afternoon. In 1905, the Colorado River actually broke through an irrigation canal and flooded an entire valley in Southern California for nearly 2 years straight. By the early 1920s, 7 southwestern states were in open conflict over the river's water. Arizona, California, Nevada, Utah, Colorado, Wyoming, and New Mexico, all competing for the same unpredictable, violent resource. The federal government knew something had to be done. The solution: built the largest dam ever attempted in human history, right in the middle of the Black Canyon, on the border of Nevada and Arizona. They would call it the Hoover Dam. Before a single cubic yard of concrete could be poured, engineers had to answer one impossible question. How do you build a dam inside a river that never stops flowing, splitting the river? The answer was as bold as the project itself. They would split the Colorado River into 4 separate tunnels, carving entirely new paths for the river directly through the solid rock walls of the canyon, and redirect the entire flow away from the construction site while the dam was being built. Engineers designed for diversion tunnels, 2 on the Nevada side and 2 on the Arizona side. Each tunnel was 56 feet in diameter, wide enough to drive 2 large trucks side by side, and stretched between 3,000 and 4,000 feet through solid black canyon rock. To understand the scale, imagine boring a hole through a solid granite mountain, large enough to fit a 5-story building inside it, and then doing it 4 times simultaneously under extreme deadline pressure with 1930s equipment. The drilling method was called drill and blast. Its massive drilling rigs, nicknamed jumbo drills, were custom built and mounted onto the backs of heavy trucks. Each jumbo rig carried up to 24 drill bits simultaneously, boring dozens of holes at once deep into the tunnel face. Workers operated these rigs in deafening noise. In tunnels choked with exhaust fumes, with almost no ventilation in the early months. Once the holes were drilled, explosive screws packed each hole with precisely calculated charges of dynamite. Everyone was cleared. The charges were detonated. The explosion shattered tons of solid rock in seconds. The shock wave, alone strong enough to knock workers off their feet hundreds of feet away. Then the mucking crews rushed in, sometimes before the dust had even settled, shoveling broken rock onto rail cars, hauling hundreds of tons of debris out of the tunnel so the drilling crews could advance and start again. This cycle, drill, blast, muck, advance, ran continuously 24 hours a day, 7 days a week for over a year. The conditions were brutal. Carbon monoxide from the engines would build up inside the tunnels to dangerous levels. Workers reported dizziness, nausea, and headaches as constant companions. Many men collapsed and had to be carried out. Despite all of this, in just over a year, all 4 tunnels were complete, a combined 3 miles of passage drilled through solid black canyon rock. Cofferdams. With the tunnels ready, the next phase began. The Colorado River had to be physically forced out of its own channel and redirected into those tunnels. This required building 2 massive temporary dams called Cofferdams directly inside the flowing river. The upper Cofferdam stretched 98 feet high and nearly 500 feet wide at its base. Thousands of workers dumped truckload after truckload of rock, gravel, and earth directly into the flowing current, fighting the river's force with sheer mass and volume. When the upper Cofferdam sealed and the diversion tunnels were opened, something historic happened. The entire Colorado River was redirected. Billions of gallons of water that had carved this canyon over millions of years were now flowing through 4 man-made tunnels bored through solid rock. A lower Cofferdam was then built downstream to block any backflow. Between the 2 Cofferdams, engineers now had something they had never had before: a completely dry canyon floor, nearly a mile long, drained of the river that had filled it since long before human civilization existed. Workers who had been drilling in darkness for months now stood on the exposed riverbed and looked up at canyon walls rising hundreds of feet above them on both sides. And all of it, every square foot of this dry floor, had to be excavated down to solid bedrock before the dam could begin. Digging to bedrock, the dry riverbed wasn't enough. Beneath the gravel and silt of the canyon floor lay layers of loose sediment and unstable material, none of which could support the weight of what was about to be built on top of it. The Hoover Dam would hold back 9.2 trillion gallons of water. The hydraulic pressure at the base of the dam wall would be equivalent to thousands of tons pressing against every square foot of foundation. Any weakness in the rock, any crack, any soft layer, any void, and the entire structure could fail. The wall could crack, it could collapse, releasing a flood, traveling at hundreds of miles per hour, destroying everything in its path. So every inch of the canyon floor and walls had to be excavated down to sound bedrock. In some areas, that meant digging over 135 feet below the original riverbed surface. High-pressure water jets, blasting at pressures exceeding 100 psi, were used to strip the canyon walls clean. Workers running these jets stood on scaffolding suspended against sheer cliff faces hundreds of feet above the canyon floor. A job they called high scaling. High scalers rappelled down the canyon walls on ropes, using bars and hammers to pry loose any rock that might fall onto workers below. A loose boulder coming down from 400 feet could kill everyone in a 50-foot radius. The high scalers had to find and remove every potential projectile before it fell on its own. Many high scalers were young men, some barely out of their teens, who had developed a reputation for performing stunts on the canyon walls. Diving off ledges into the river, doing handstands on outcroppings hundreds of feet in the air. To the workers below, There was something between circus performers and guardian angels. Once the canyon floor and walls were stripped to clean, solid bedrock, engineers conducted load-bearing tests at multiple points across the entire foundation. Only when every test passed was the first concrete truck allowed to roll forward. Here is the problem that nearly killed the entire project before it started. Concrete generates enormous heat as it cures a chemical reaction called hydration that releases thermal energy throughout the hardening process. For a normal slab, this isn't a problem, but the Hoover Dam wasn't a slab. It was a 726-foot tall, 660-foot thick wall containing over 4.4 million cubic yards of concrete. If that entire mass had been poured as a single continuous pour, the heat trapped inside would have been catastrophic. Engineers calculated that the dam would have taken over 125 years to cool on its own, and long before it finished cooling, the uneven thermal stresses would have caused massive internal cracking that would have destroyed the structure entirely. The solution was radical, and it had never been attempted at this scale. Instead of one continuous pour, engineers divided the entire dam into 215 separate interlocking concrete columns. Each column was poured individually in small blocks roughly 5 feet tall, with carefully planned gaps between each column. This allowed each section to cool and contract independently. But that alone wasn't enough. Inside every single concrete column, workers embedded a network of thin steel pipes, each just 1 inch in diameter, running through the concrete in a grid pattern from base to top. In total, 582 miles of cooling pipe were installed inside the dam, more pipe than a distance from the dam site to Los Angeles and back. Ice-cold water, chilled by large refrigeration plants built directly on site, was pumped continuously through these pipes 24 hours a day. The cold water absorbed heat from the surrounding concrete and carried it away, cooling the dam from the inside out. At peak operation, the refrigeration plants were processing over 1,000 tons of ice per day just to keep the cooling water cold enough. Once a section cooled to its target temperature, workers injected a special grout mixture into the joints between columns, permanently bonding the entire structure into one single monolithic mass with zero thermal cracking. The result, a dam that cured in 18 months instead of 125 years. At peak production, a new batch of concrete was delivered to the dam every 78 seconds. 6 million tons of concrete were placed in under 2 years, a world record that stood for decades. Take towers and powerhouse. As the concrete columns rose higher week by week, a parallel construction operation was underway on both canyon walls. The intake towers, 4 concrete intake towers, each rising over 395 feet above the canyon floor, were constructed on the Nevada and Arizona rims. These towers would serve as the dam's control system, drawing water from Lake Mead and directing it into the Penstocks' massive steel pipes, 30 feet in diameter, embedded inside the dam itself. The penstock pipes were so enormous that workers assembled them from the inside, welding curved steel plates together while standing within the pipe. Wearing welding masks, the walls curving away on all sides like working inside an industrial tunnel. Water flowing through the completed penstocks drops over 500 vertical feet before reaching the turbines. By the time it arrives, it is traveling at over 85 miles per hour. That velocity drives 17 massive electrical turbines in the powerhouse at the base of the dam, generating enough electricity to power 1.3 million American homes. The river returns. As the dam neared completion, the final act began. The 4 diversion tunnels, which had carried the entire Colorado River for years, were permanently sealed. Workers poured concrete plugs deep into each tunnel, each plug hundreds of feet thick, blocking the passages that had redirected one of the continent's greatest rivers. The Cofferdams were demolished. The Colorado River was finally allowed to approach the dam. The water rose slowly at first, seeping into the space behind the dam, filling the canyon floor. Then faster. Engineers monitored every sensor, every pressure gauge, watching for any sign of failure. None came. The dam held. Lake Mead began filling. It took over 2 full years for the reservoir to reach capacity, a body of water stretching 112 miles behind the dam, containing 9.2 trillion gallons. It's the largest reservoir in the United States. The Hoover Dam was officially completed on March 1st, 1936, 2 full years ahead of its original schedule. A project so complex that government engineers had estimated 7 years to complete. Private contractors finished it in 5. Over 21,000 people worked on this dam. They came from 46 different states, many walking hundreds of miles just to reach the job site, willing to work in any conditions for $4 a day. 112 of them did not come home. They died in tunnel collapses, from heat stroke, from falls, from equipment failures. Their names are recorded in a plaque at the base of the dam that most visitors walk past without stopping. What they left behind wasn't just a concrete wall. It was the foundation of an entire civilization in the American Southwest, without the water and power controlled by the Hoover Dam. Cities like Las Vegas, Phoenix, and Los Angeles could not exist at the scale they do today. Over 40 million people in the southwestern United States now depend on the water and power that flows from this single structure built by hand in the desert in the middle of the Great Depression. The Hoover Dam stands today exactly as it was designed to stand, 726 feet tall, holding back 9.2 trillion gallons, generating over 4 billion kilowatt-hours of electricity every single year. After nearly a century of continuous operation, engineers say it could stand for another 1,000 years. If you want to understand how the world's greatest structures were engineered to last centuries, Quiet Tech Process covers the full story. Subscribe so you don't miss the next one.